All right, so here are the notes on annuities. First, if you recall the compound interest formula, here's a version of it. A equals P 1 plus R raised to the T power. You may have seen 1 plus R over N raised to the T N T power and so on. But pretty much that is how to find the value of A when you have a fixed amount of money that's deposited and at the annual interest rate and it's compounded just one time a year. Now, usually money is going to be invested in small amounts at periodic intervals. An example of this would be an IRA. So for annuities, an annuity is a sequence of equal payments made at equal time periods, and an IRA is an example of this. The value of an annuity is the sum of all deposits made plus all interest paid. All right, so here is the formula, and you're going to see a lot of the stuff we've seen when we talked about the compound interest formula, except this one doesn't have the N and raised to the NT. But if P is the deposit, so P, like your initial amount, your deposit, made at the end of each compounding period for an annuity at R%, so that R, we're going to convert it to a decimal, either dividing it by 100 or starting at the decimal and moving it 2 to the left. R% annual interest rate compounded N times per year, so N is still the number of times compounded in a year. The value A of the annuity after T, which is the number of years, is applied by this formula. Okay, so I'm going to try to keep this formula in view. I'm going to read through this problem, find all the information I need, and work it out. So let's write down the letters I need to identify: A, P, R, N, and T. All right. So at age 25, to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pays 7.5% compounded monthly. The first question says, how much will you have from the IRA when you retire at age 65? Okay, so let's start with, we don't know what A is. That's the answer we're looking for. P is the initial amount, what we deposit, which is $200. R is the interest rate, so it's 7.5. We can move it 2 to the left, which becomes 0.075, or divided by 100. Either way, you still come up with 0.075. N is the number of times it's compounded in a year, so it's compounded monthly. And then T is the amount of years. Well, for this one, be careful. You're 65 when you retire, but you start when you're 25. So you take away 25 from 65. And that's actually going to give you 40 years. So that's how I got all the numbers. So for part A, we'll work this out. We'll plug all these numbers in. So A equals 200. Brackets, parentheses, you can use double parentheses. I'll use the brackets here, but when I type it into the calculator, I'll use parentheses. 1 plus R, 0.075, divided by N, which is 12, raised to the 12, which is N again, times T. So notice I'm just plugging into this formula here. T is 40, minus 1, bracket, all divided by R divided by N, so 0.075 divided by 12. Now we're going to just take this and plug it into the formula. So the way I'm going to do that is here. I'm going to go to Desmos. So let me fit this on here with this here. So there's the formula. I'm trying to move it up as much as I can. There we go. All right, so I'm just plugging in, but maybe you want to see the screen what I'm doing. So here is the whole thing. Sorry about that lamp right there. So we're going to start with principal amount 200. Parentheses, I'm going to use double parentheses. 1 plus 0.075 divided by 12. I'm going to arrow out of this, arrow out of there. I need to raise it. And here it's 12 times 40. You can't do 12 times 40 because this is what happens. Notice it goes down there. So what you want to do is when you do the 12, before you start the 12, you want to put open parentheses. Then 12 times 40. Close the parentheses. Arrow out. And then minus 1. Arrow out again. Now we're going to divide this all by 0.075 divided by 12. And I don't have to hit enter because I can see the answers right there. It's 604,764.43, and I'm not looking at the third number, 4. Since that 4 is less than 5, that means the 0.43 stays the same. If that 4 was a 5, it would become 0.44 because it rounds up 1. So it's 0.43 because that 4 right there after the 3 is not bigger than 5. All right, so let me transfer this answer onto my paper. So the answer I got again was $604,764.43. All right, for part B, it says to find the interest. So your interest is going to equal the value of the IRA minus the total deposits. And so let's go ahead and talk about this. So the total deposits actually relies on 3 things. It's going to depend on the deposit, which is 200. Actually, let me just write this out. So interest equals the value of the IRA, which we just got a second ago, 604,764.43 minus the total deposit. So we start with $200. That's how much we're depositing a month, times the number of times, 12, and the number of years, 40. Now you can take this answer and type it into your calculator. So I'm gonna just type in this number first real quick. All right, so right now I have just typed in that answer. So $604,764.43 minus the total deposits, which is 200 times 12 times 40. And here we can see the interest is actually $508,764.43. So there we can see that answer right there. So let me go ahead and transfer that over. And that's going to be my interest rate. So that's the formula I used to figure this out. So I is approximately or equal to $508,764.43. So there's part A and part B.